Okay, what fractional exponents mean on radicals is the same thing as square rooting. Let me give you one. If you remember one, this is the easiest one to remember. So let's say you have the square root of 16. Okay, of course that's 4. But that can also be rewritten as 16 to the 1/2 power. Or 1/2 could be, of course, as a decimal, 0.5. 1/2 power means square root. Let's take a look at our calculator. I do that a lot actually on the calculator because I think it's faster than doing, let's see, clear. I think it's faster than doing second square root, since square root is a blue key. If I want the square root of 16, oftentimes I just do 16 to the 1/2 power like that. See, it's the same thing as the square root of 16. Or 16 to the power 1/2, that's 4. That means the square root of 16. They all mean the square root of 16. Okay, so let's say we want to do the third root of 27. Remember, what we're looking for is 3 things now that make 27. So the third root of 27 is the same as 3, 3, 3. So you need 3 packages to come out as a 3. So that should be 3. Okay, well, I can also write that same notation as 27 to the third root. So on a calculator, now it's much harder to find the third root key. You got to go into the, let's see, where is it? It's under math. Yeah, there it is. There's the third root of 27. That should produce 3. Now I think it's much easier to take it to the 1/3 power. Now you can't, 1/3 is 0.33333 repeating, so if you're going to do that as a decimal, you just can't say 0.3 because that's not enough. See, that's the 3/10 power. So 27, if it's much more difficult to put it in as a, I don't know how many you need for your calculator to finally round it to 1/3. That looks like that was enough. So you can put it in as a decimal, but fractions are really what that means. Okay, so the one to remember is x. If we want the square root of something, now that's the same thing as something to the 1/2 power. Okay, now there's some invisible numbers on this square root. Square root, like on the 16, really where it came from was 16 was really 4 times 4, so we need a package of 2 of them to come out. So there's an implied 2 right there, a package of 2. Like this one meant a package of 3. So if we wanted the 4th root of 16, that means we need a package of 4. 2 times 2 times 2 times 2. There's a package of 4. The 4th root of 16 is 2. So if we go 16 to the 4th power, see, there's the 2. Okay, so there's that little tiny number inside there is the package size. Okay, so really, we don't write it when it's square root. We just assume that means packages of 2. And there's also a power on the x right here that's an invisible 1. So if I put these invisible numbers on there, that's the package size of 2, and that's a power of 1. That helps me remember how to build the fraction. The 1 is the power on the x, and the denominator, the 2, is the package size. Now, I say that because what we're going to get to is, okay, if the third root of 27 means package size of 3, so 3 times 3 times 3, that would be 3. If that's 3, because we can break that into a 3 and break it out, so that means we could have rewritten that as 27 to the 1/3 power. Okay, that would be 3. What about 27 to the 2/3 power? What does that mean? Okay, I'm going to see what it does on my calculator. 27 to the power 2/3. Okay, it's 9. So let's investigate what this part right here means. That's how come I wrote this in the notes up there. This is the one that's going to be the most handy. See, the 2 is where the 1 is. That's the power on the x. So what this really means then is 27 has a power on, so the 27 has got a power 2 on it, and then the denominator is the root number. So that means it's the third root of 27 squared. Now, this is an exponent and this is an exponent. In order of operations, multiplication and division are tied, so it doesn't really matter which one of these you do first. We could do the squaring first. So if I do the squaring first and go big, I'm going to go like this. I'm going to go big and do the square first. 27 squared is 729. See, I just did the power, I did the exponent first. And now I need something, there's got to be 3 somethings to get in here, and I happen to know it's 9 times 9 times 9 is 729. So a package of 3 of those will break out as a 9. And sure enough, if I do that on my calculator, if I take that to the 1/3 power, see, there's 9. That's 729 to the 1/3 power. But I needed my calculator sometimes for that. I'm going to go this one, and I'm going to go small first. What I mean by that is I'm going to take the 3rd root of 27 first. The 3rd root of 27, and then I'm going to square it. So 27 is 3 times 3 times 3. So I can break that package of 3 out as a 3. So that gives me a 3, and then the square is still on it, and there's the 9 also. So a fractional exponent means that's what this is for. The top number is the power on the number, and the bottom part of the fraction is the root that you take it to. So it's 2 things. It's a power and a root. It's a power and a root combination. Okay, so here we just want to write each expression in exponential form. Exponential form means as an exponent. So there's an invisible 2 right there. Okay. The package size is 2, and then we want to cube it. Now remember, x to the 1/2 means the square root of x. See, the top number is the power number, and the bottom number is the root number. Okay, so that's telling me that right here it's the root. So the root is, this is 10, the root number is the 2, and the power number is the 3. That's 10 to the 3/2 power. That's how you can rewrite that. So this one, it wants the 3rd root of 4 and then all to the 5th. So that's 4. Okay, the root number is on the bottom, the power number is on the top. That's 4 to the 5/3 power. This is A. Okay, the power is on the top, the root is on the bottom of the fraction. That's A to the 4/3. This is just 1/2. Square root means 1/2. There's the 1, there's the 2. Okay, so there's the implied 2, so the power is 5, so that's m to the 5/2 power. Okay, 5m is in this one now, so that's all, the root and the power is on the 5m, so we've got to grab it so it catches the 5 and the m. So there's the power and there's the root. So this is b to the 6/5 power. 3a, the entire package, there's the power, there's the root. So the entire package to the 2/3. Okay, so now write each one of these the other way around in radical form. Radical form means with the square root. Okay, the bottom number is the root number, so it's the 3rd root of 4. Now, it doesn't really matter if you put it like this, all of it to the 5th, or you can say the 5th power can be in there. It doesn't really matter. Okay, so this is to the 1/4 power. That means the 4th root of 5 to the 1st. You don't really have to put the 1 there. So this is the package 3b. Okay, let's see, I don't need to do the parentheses because the square root symbol is going to be the parentheses, so it's the 5th root of 3b. See, you could put it in parentheses if you wanted to. So there's the 3b, and now just to be clear, a lot of times people put this whole thing now in brackets to the 4th like that. You don't really have to do that. I mean, this would be acceptable as long as you get the b underneath the thing and then put it to the 4th like that. But probably this is how you will see it most of the time when there's more than one thing in there. So this is 10p squared. It's the fifth root of all of that. And then all of that is squared again. Okay, so here we have the sixth root of 2x all to the seventh. Okay, negative, it's okay to just leave it a negative power like that, but remember what a negative power does. If we have 2 to the negative 1, that means all of this belongs in the other part of the fraction. So it means the 2 to the 1 is in the denominator. So it means 1 over all of that. So we could do it like this. This negative means 1 over, okay, and then I've got the sixth root of 2k all to the seventh. Okay, 1/2 is just square root. This is the square root of 6m. As long as you get the m inside the bracket, you don't have to worry about it, inside the radical. So we have the third root of 4n, and then all of that is squared. Okay, so to simplify these now, so here's what we're talking about. So it's the third root of all this. So it's the third root of 343 v to the 9. Okay, so I'm looking for packages of 3. Now we want to try to do this without a calculator, so a lot of these will be non-calculator problems. So that's probably, well, that one's big enough, I'm going to actually use my calculator. 343 to the 1/3 power is 7. So that really means 7 times 7 times 7. And then v as one package, v as another package, v. There's the 9 v's. See, that can come out as a 7. That package, that group of 3 can come out as a v. Theirs comes out as another v, and that one comes out as another v. So they all came out. So I have 7v to the third all on the outside. Okay, 19. All right, so we have the third root of 125n to the sixth. Then I'm going to square it all. So I'm going to get smaller first. 125 is 5, 5, 5. N to the 6 in packages of 3 is n, and then n. So the 5s can come out as a 5. N's can come out as an n, and n's can come out as an n. So it's 5n squared. So the parentheses part became 5n squared. But now all of that is to the second power. So now we can take that on there. So that becomes 25, and a power is multiply. So 25n to the 4. So it's easier without a calculator, especially, to get smaller first and then grow. Okay, so I'm just going to remember at the end that the negative means flip it over. So really what I need is the third root of 27b to the third. Then I'm going to fourth that. Okay, 27 is 3 times 3 times 3, and then b3. Okay, put it in groups of 3, so that can come out as a 3, and that comes out as a b. So inside there I have a 3b now, all to the fourth. Okay, that means 3 times 3 times 3 times 3, that's 81. And then b to the fourth is b to the fourth, so it's 81b to the fourth, but then I still have this negative, which means turn it upside down. So it's 1 over 81b to the fourth. Okay, the third root of 343b to the sixth. Then I'll square it. So I'm going to go small first. So I already know that that means 7 times 7 times 7 from before, and then BBB and BBB. So those come out as a 7. There's a set of B's, and there's a set of B's. So on the outside it's 7B squared. And now I still have all of that to the second power. So 7 to the second power is 49, and B22 is B4. And that's that's what a fractional exponent does.